We've all looked up at a vibrant sunset and wondered what it would be like to grab a piece of the sky. The idea of clouds made entirely of cotton candy is a common childhood fantasy. It's easy to imagine pink and blue sugar filling the horizon, providing a sweet snack to anyone who can reach them. While they look like drifting landmarks, these clouds are the mechanical gears of Earth's climate system. Replacing water vapor with spun sugar breaks the systems that keep the planet habitable. To see why, we can track how sugar behaves in the three roles our atmosphere performs, beginning with the global water cycle. This molecular comparison highlights the difference in mobility between water and sugar. On the left, water transitions between liquid and gas. On the right, sugar remains a static crystal that cannot evaporate. This movement is how the planet survives. Water-based clouds act as a delivery system, lifting moisture from the oceans and carrying it to the center of continents. Sugar clouds, however, cannot move. Because sugar cannot evaporate and travel through the air, the global delivery of water stops. Within days, rainfall across the entire planet ceases. The consequences follow quickly. Rivers stop flowing, groundwater reserves empty, and crops fail as the soil loses its moisture. Land that was once fertile turns to dust. Without the constant replenishment of rain, the Earth's surface dries out completely. Sugar's inability to travel means the freshwater delivery system fails, and the first major role of the atmosphere is lost. The breakdown moves from global weather to the physical world on the ground. Spun sugar reacts poorly to its environment. It dissolves almost immediately when it touches moisture. Since the air always contains some residual water vapor, these giant sugar clouds would begin to melt the moment they formed. Instead of water, the sky would release a constant, heavy shower of thick syrup. This syrup coats everything. Cities become encased in a hardening residue that glues buildings, streets, and vehicles in place. Travel becomes impossible. Aircraft are forced to stay on the ground because sugar buildup would clog engines and coat the wings, making flight dangerous. The simple chemical reaction of sugar dissolving creates a cleanup crisis that stops all modern travel and infrastructure. The breakdown reaches the food chain and the planet's temperature control. Birds are the first to suffer. Their feathers become matted with sticky residue, making it impossible for them to fly. Meanwhile, the sudden abundance of sugar on the ground attracts massive swarms of ants and flies. These insects multiply rapidly, overwhelming local ecosystems. Beyond biology, we lose our temperature shield. Standard clouds manage heat by bouncing incoming solar radiation back into space, while keeping surface warmth tucked in below. Cotton candy clouds fail this task. They allow solar radiation to pass straight through to the ground, while surface heat escapes into the atmosphere without being trapped. Losing the ability to regulate solar radiation causes the temperature to swing from scorching heat to freezing cold every 24 hours. Reflective, looking at a city encased in thick amber syrup, the reality of the transformation becomes clear. What began as a childhood dream of a sweet paradise ends as a landscape that cannot support life. This dot experiment clarifies why we rely on standard water vapor clouds. They manage the difficult task of moving water, protecting the food chain, and keeping the surface at a stable temperature. The way our atmosphere handles water allows life to continue, making the real sky a more stable home than a candy paradise.
Hey explorers! Like and subscribe! Let's spark your curiosity!